Hello everyone and welcome back. I am Benjamin Williams and today we're going to be doing another lab within the infrastructure within Boson. Today we're going to be doing a lab on configuring multiple HSRP groups. So let's read our objective for this lab. It says configure two hot standby routing protocol HSRP groups and verify the configuration. Okay, so if we look at our topology, we're going to read through the topology here in a second. But if we look at our topology, we know that we're going to be configuring hot standby routing protocol on our distribution layer switches because that is a characteristic of the distribution layer switches. As we know, our access layer switches are going to be giving access out to our clients. So let's go ahead and look at our lab topology that we're going to be working with. It says for this lab, your network design will include 4 switches. We have A switch 1, A switch 2, as we see right here, and D switch 1 and D switch 2, as we see right here. It says each switch is connected to one another by Ethernet link. It says A switch 1 and A switch 2 are access layer switches, and D switch 1 and D switch 2 are distribution layer switches. 2 PCs named Client 2 and Client 1 are connected to the access layer switches on the Fast Ethernet 03 port. Even though there are only 2 access layer switches in the network design, each client represents a group of workstations. Since each group of workstations generates a significant amount of traffic, you want to route each group to a different switch, but still provide a redundant default gateway for them in the unlikely event that one of the switches fails. And that is always smart because you do not want to have a single point of failure. So since basically what it's saying is since it's going to be basically a group of workstations off of this A switch and a group of workstations off of this A switch. So they're going to be generating a lot of traffic. So to load balance that traffic, we're going to be using one distribution layer switch as the default gateway for this group of clients, and this distribution layer switch for the default gateway for these group of clients to load balance the traffic. And then if one of them fails, the other group will be able to just use the other distribution layer switch because we have redundancy because we're going to be doing 2 HSRP groups in this lab. Okay, so it says upon the initial loading of this lab, all devices will be configured with the IP addresses, virtual LANs, VLANs, and spanning tree commands needed for connectivity. Okay, so we're just taking a look at our lab topology. All right, so everything is looking good. So I've already read through all of the command summary for this lab and the descriptions as well. And I've reviewed the IP address information, and this is always good information to have for troubleshooting purposes and also to make sure that your IP address information matches up on each device. So that is good information to have. All right, so we're going to keep our lab topology up here in the top left. We're going to be doing our readings and our lab tasks in the top right. And we're going to be doing our configuration down here at the bottom, okay? So let's go ahead and get into lab task number 1. It says verify basic connectivity and configure hot standby routing protocol. It says this task involves configuring hot standby routing protocol on the distribution layer switches, which that is a characteristic of the distribution layer switches, okay? So task number 1, it says when devices are assigned to an HSRP group, how does the group function? So it functions as one of them will be the active router and the other distribution layer switch will be the backup. So basically if the active fails, the backup or the standby, that's the right keyword, the standby will take over for the active, okay? And they will use the same virtual IP address. So it says briefly explain hot standby routing protocol groups. Well, you configure a group. Let's just read the description. All right, it says an hot standby routing protocol group has one active router and one standby router. The highest priority is determined by the device in the group with the highest IP address on the interface configured for a hot standby routing protocol, or if preemption is enabled, the priority setting that is configured on the devices. All other routers in the hot standby routing protocol group transition to the listen state and remain in that state until either the active router or standby router fails. In accordance to RFC 2281, the IP address assigned to a hot standby routing protocol group must differ from the IP addresses assigned to all routers and hosts on the LAN, including those assigned to other HSRP groups, and this IP address should belong to the primary subnet on the LAN. In this task, you will configure an IP address for hot standby routing protocol that is not used on a physical interface or any device. A virtual media access control MAC address is used to identify the hot standby routing protocol group to clients. The virtual MAC address for hot standby routing protocol groups is in the form of 4000 C7AC XX, where XX is a hexadecimal value identifying the hot standby routing protocol group number. This MAC address will also be used on all hot standby routing protocol interfaces on the hot standby routing protocol group. Okay, so that was not really a brief explanation, but it was a good explanation of hot standby routing protocol group, hot standby routing protocol. All right, so it says verify that all non-hot standby routing protocol IP addresses on each device have been configured correctly. All right, so let's bring up our IP address information in the top left so we can verify everything, and we're going to start on router 1. Let's do an enable, and let's do a configure terminal to go into global config mode. Oh, we didn't have to do that. Let's go exit. Let's do a show IP interface brief. All right, so let's just confirm our fast Ethernet 00 IP address. We see that it matches up right here. We see 172.16.253.2 for our fast Ethernet 00 connection, so that looks good. And our fast Ethernet 01 interface looks correct as well. It has an IP address of 172.16.253.14, and we see that in our output and the CLI, so that looks good. Let's move on to router 2. Do an enable. Let's do a show IP interface brief. All right, our fast Ethernet 00 connection, we see it has an IP address of 172.16.253.18, and that matches up with our IP address table. And also our fast Ethernet 01 interface has an IP address of 172.16.253.6. That matches up as well. So let's go ahead and move on to A switch 1 and A switch 2. We're going to start on A switch 1. Let's do an enable, and let's do a show IP interface brief. And we see that the VLAN 1 IP address matches up in the CLI. It has a IP address of 172.16.3.10. That looks good. Let's move on to A switch 2. Let's do an enable. Let's do a show IP interface brief. This VLAN 1 has an IP address of 172.16.3.20. So that is confirmed in our IP address table. So let's go ahead and move on to our distribution layer switches, D switch 1 and D switch 2. All right, let's bring up D switch 2 too. Okay, so we're going to start on D switch 1. Let's do an enable, and let's do a show IP interface brief. And we see that our VLAN 1 IP address is 172.16.3.3. That matches in our table, so that looks good. Our fast Ethernet 03 has an IP address of 172.16.253.9. That matches. Our fast Ethernet 04 IP address is 172.16.253.5. That matches. And lastly, we have our fast Ethernet 05 IP address of 172.16.253.1. That matches up. So everything is looking good right there. So let's go ahead and move on lastly to D switch 2. Let's do an enable, and let's do a show IP interface brief. All right, and we can confirm our VLAN 1 IP address, which is 172.16.3.2. That matches up in the CLI. Let's move on to fast Ethernet 03. It has an IP address of 172.16.253.10. That matches. Fast Ethernet 04, 172.16.253.17. That matches up. And lastly, fast Ethernet 05, it has an IP address of 172.16.253.13, and that matches. So all of our IP address information looks to be well. Okay, so let's move on to task number 4. It says from client 1, ping the default gateway, which is the VLAN 1 interface on D switch 1, which has an IP address of 172.16.3.3. So let's bring up client 1. And let's ping its default gateway. Let's do a ping to 172.16.3.3. Can it ping its default gateway? And it can. We're getting our replies from D switch 1. Okay, so let's also move on to question number 5. It says from PC2 or client 2, ping the default gateway, which is the VLAN 1 interface on D switch 1, which has an IP address of 172.16.3.2. So let's bring up client 2. All right, and let's do a ping to 172.16.3.2, which is client 1's default gateway, which is D switch 2, and we're getting replies. So we got 5 sent and 5 received. So all of our pings were successful. All right. It says from client 1 and client 2, ping router 1's fast Ethernet 00 interface, which has an IP address of 172.16.253.2. All right. So let's go back to client 1 first, and let's do a ping to 172.16.253.2. And we're able to ping router 1's fast Ethernet 00 from client 1. Let's move on to client 2. Let's do a ping to 172.16.253.2. And we are able to ping the fast Ethernet 00 interface on router 1 as well. So we see 5 sent and 5 received. So everything looks to be well there. All right, it says question number 7. It says, how can you set up the network so that all computers represented by client 1 use an IP address on D switch 1 as the primary switch for their default gateway, but fail over to the same IP address on D switch 2 for their default gateway in the event that D switch 1 fails? Well, we'll have to set up either hot standby routing protocol or virtual router redundancy protocol. So we would have to set up some type of redundancy for our default gateways, and those are the two. And then we also have gateway load balancing protocol. That is Cisco proprietary, but that is another redundancy protocol that we can activate within our network if we had all Cisco devices. Okay, so let's go ahead and move on to question number 8. It says on D switch 1, it says create a hot standby routing protocol group with a group number of 10 and an IP address of 172.16.3.252. Use hot standby routing protocol priority of 120. Okay, so let's go to D switch 1 first. Let's do a conf T to go into global configuration mode, and let's go into interface VLAN 1. All right, and let's do a standby 10. We want to configure an IP address of 172.16.3.252. All right, say enter there. Let's do a standby 10, and let's do the priority of 120. Say enter there. All right, and it says on D switch 2, create a hot standby routing protocol group with a group number of 10 and an IP address of 172.16.3.252. and use a hot standby routing protocol priority of 90. So let's go ahead and move on to D switch 2. Let's do a configure terminal. Let's go into interface VLAN 1. Let's do a standby group number 10 so it matches on both D switches. And let's do the same virtual IP address of 172.16.3.252. Say enter there. And as we can see, it has taken the standby role, and D switch 1 should have taken the active role because we configured a higher priority on D switch 1. Right now, D switch 2 has the default of 100, and we're about to change that now. Let's do a standby 10, and let's do a priority of 90. All right. So it says which devices need their default gateway changed in order to take advantage of the new hot standby routing protocol of group 10. Well, we need to change A switch 1's default gateway, and we also need to change client 1's default gateway. All right, so it says on the devices that you noted in the previous step, change the default gateway to 172.16.3.252. So just confirming that we did configure this distribution layer switch to be the active. So we need to change the default gateway for this A switch, and we need to change the default gateway of this client PC. Okay, so let's go over to A switch 1. Let's do a configure terminal. Let's do a IP default gateway of 172.16.3.252. All right, that looks good. Let's go over to our client PC1. Let's do an IP config. Let's do an IP config / all to see its default gateway now. So we need to change this because it's still using dswitch1's actual IP address, and we want to use that virtual IP address. So let's change that. Let's do an IP config / default gateway 172.16.3.252 to enter there, and let's do an IP config / all to confirm that change has been made, and it has. We can see the default gateway change right here in the output of the CLI. So that looks good. All right, so it says, how can you set up the network so that all computers represented by client 2 use an IP address on dswitch 2 as the primary switch for their default gateway, but fail over to the same IP address on dswitch 1 for their default gateway in the event that dswitch 2 fails? Well, we need to set up a redundant default gateway using either HSRP, VRRP, or GLBP. And in this lab, of course, we're doing HSRP. So let's go ahead and set that up so that if one of the distribution layer switches primary default gateway goes down, it can fail over to the standby switch. And then the clients will still be able to get out to the internet and do what they need to do. So step number 13, it says on dswitch 1, create a hot standby routing protocol group with a group number of 20 and an IP address of 172.16.3.254 and use a hot standby routing protocol priority of 90. Okay, so let's go over to dswitch 1. All right, and let's do standby 20, and we want to do an IP address of 172.16.3.254. Okay, and let's do a standby of 20, and let's do the priority change, and let's set it to 90. All right, so that looks good right there. So the next step is telling us to do, it says on dswitch 2, just create a hot standby routing protocol group with a group number of 20 and an IP address of 172.16.3.254. Use a hot standby routing protocol priority of 120. So let's go ahead and go over to the distribution switch 2, and let's do a standby of 20. Let's do an IP address of 172.16.3.254. All right, press enter. Let's do a standby 20 IP address of let's do not IP address, priority of 120 over here on the distribution layer switch, and hit enter there. All right, so it says which devices need their default gateway changed in order to take advantage of the new hot standby routing protocol group 20. Well, we need to do the change on this distribution, or this this access layer switch right here, and we need to change the default gateway on this client 2 PC as well. So let's start out on the, it says on the devices that you noted in the previous step, change the default gateway to 172.16.3.254. So let's go ahead and do that now. So let's go over to access switch 2. Let's do a configure terminal. Let's do an IP default gateway of 172.16.3.254 and enter there. And let's go over to our client 2 PC. Let's do an IP config / default gateway of 172.16.3.254. And let's do an IP config / all to confirm that change. And we can see that confirmation is there within the CLI. It is now using that virtual IP address that we configured for HSRP. So everything is looking good, okay? So it says task 2, verify hot standby routing protocol configuration. It says this task involves configuring hot standby routing protocol on the distribution layer switches. Okay, so it says on D switch 1 and D switch 2, display the hot standby routing protocol configuration. You will use this output in the following questions. So let's go to D switch 1 first. Let's do a do show standby. Do show standby. All right, and let's go to distribution layer switch 2, and let's do a do show standby. All right, so here's our outputs right here. So it says what device is the active router for hot standby routing protocol group 10. So if we look at the output, we can see that D switch 1 is the active router for group 10, and we can see that from the output it says state is active, so we're able to determine that based off of the output that we see. It says for step number B, it says which device has the higher priority for HSRP group 10. Well, we can see right here that the distribution switch 1 has a priority of 120, and the D switch 2 group 10 router has a priority of 90. So we see that D switch 1 has a higher priority. Okay, so it says why are both HSRP groups on separate devices assigned the same IP address? Well, we give them the same virtual IP address in case one of the distribution layer switches fails. If that happens, the standby switch will take over as the active, and the end devices will still be able to get out into the internet. So as we know, we do not want to have a single point of failure within our networks. So configuring HSRP is a way to allow devices to have multiple default gateways. In case one of the devices fails, it can fail over to another device, and end clients or end people in general would not have any knowledge that a failure has happened, because they're still able to get out to the internet and do anything that they want to on the internet. Okay, so it says which device is the active router for hot standby routing protocol group 20. How did you determine this? Okay, if we look at the outputs, we can see that D switch 1 is the active router for group 20. And we're able to determine this by the output. It says state is active right here. If we go over to D switch 2, we can see that it is the standby for group 20. Okay, it says which device has the highest priority. I think this output got cut off, so let me hit that again. So we see that the priority on D switch 2 is actually higher. It has a priority of 120, and on D switch 1 it has a priority of 90. But we do not have preemption enabled. So right now, this distribution switch 1 is the active for group 20. But if we enable preemption, D switch 2 should take over as the active router. Okay, so it says for question number 2, it says, is a group number required in order for HSRP to be configured? And no, it's not. It does not need a group number to be configured. If it's not configured with a group number, it will use the default group number, which is 0. All right, so for question number 3, it says, what is the default hot standby routing protocol group number? That is 0. We can confirm that with this output. Yep, it says HSRP default group number is 0 if no group number is specified. Okay, so it says for question number 4, it says verify that client 1 can still ping router 1's fast Ethernet 00 interface, which has an IP address of 172.16.253.2. So let's go to client 1. Let's hit the up arrow a couple of times, get back to that ping. Let's see if we can still ping the router, and we can see the replies coming in right here, and we can see that we sent 5 pings and we received 5 pings. So that looks great. So let's move on to task number 3. It says assign HSRP preemption. It says this task involves configuring D switch 1 to be the active HSRP router, and for hot standby routing protocol group 10, and for D switch 2 to be the hot standby routing protocol active router for hot standby routing protocol group 20. Okay, so it says how can you guarantee that a specific switch becomes the active router in a hot standby routing protocol group? Well, first you need to configure the priority to be higher than the default, and then after that, to make sure that it stays as the active, we need to enable preemption on our distribution layer switches, because HSRP does not have preemption enabled by default. Okay, so it says what is the default priority for HSRP groups? The default priority is 100. Okay, so let's go ahead and move on to question number 3. It says, has D switch 1 become the active router for hot standby routing protocol group 10? If not, why? So if we look at the output, we can see that D switch 1 is the active router for group 10. So that answers the first question. We don't have to answer if not why, because it is the active. It says enable preemption for hot standby routing protocol group 10 for D switch 1 and D switch 2. So let's go ahead and do that. Let's do a standby. We're going to start on D switch 1. Let's do a standby 10 preempt. Hit enter. Do the same command over here on D switch 2. Let's do a standby 10 preempt. Oops, did it go through? Yeah, preempt. Just wanted to make sure that went through. All right, it says, has D switch 2 become the active router for hot standby routing protocol group 20? If not, why? So we can see right here that D switch 2 has not become the active router for hot standby routing protocol group 20, and that is because the preemption down here is disabled. So when we first configured it, we configured hot standby routing protocol on D switch 1 first. So because of that, it went on ahead and assumed the active role, and then after that we configured it on D switch 2, and since preemption was not enabled, it's not going to preempt the device by default, so we had to enable preemption. All right, so it says right here, it says enable preemption on hot standby routing protocol group 20 on D switch 1 and D switch 2. So as soon as we do this, D switch 2 should take over as the active router. Let's do standby 20 preempt. All right, let's do the same command over here on D switch 2. Let's do a standby 20 preempt. And as we can see right here from our syslog message, that D switch 2 has taken over as the active router for this hot standby routing protocol group. So it says verify the configuration. Has D switch 2 become the hot standby routing protocol active router for group 20? So we see it in the syslog message, but let's just pull up the output. Let's do a do show standby. And as we can see now, D switch 2 is the active router for group number 20. We're able to see that right here. It says state is active. And let's go to D switch 1. We can see that preemption was enabled, so it has assumed the standby role for group number 20 now. So let's do a do show standby over here as well, and we can see that it is in the standby mode. So if D switch 2 were to fail, it would take over as the active. So it says verify that connectivity still exists on client 1 and client 2 by issuing a ping to router 1's fast Ethernet 00 interface, which has an IP address of 172.16.253.2. So let's go over to client 1 and client 2, and let's first issue that ping to router 1, and we're still able to ping router 1 from client 1. We see that we sent 5 pings and we received 5 pings. So let's go over to client 2, confirm that we can still ping the fast Ethernet 00 interface on router 1, and we see that we sent 5 pings and we received 5 pings. So it looks like this is the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correct. And we did. So thank you guys for watching this one, and I'll see you in the next one.